Okay, good morning everyone. Am I audible? Please confirm me anyone. Am I audible or not?
Audible, sir.
Okay, good morning everyone. Am I audible?
Yes, sir.
Okay. So let's start. We have discussed in last classes. This is process instrumentation and control. Different types of benefits, different types of requirements of this process instrumentation and control. Okay. So I think, and I share the class note in your Google Classroom portal. I think all of you read this carefully. So anyone, any doubt or any questions, so please ask me from the previous part. We have discussed this process characteristics of the process instrumentation and control part. Okay. And we have to conclude that is benefits. What is the basic benefits of process industries or process control instrumentations? Okay. And also we have to discuss difficulties of process control implementation. Okay. And last we have to discuss what is the basic requirements. What is the basic requirements of process control industries or process control implementation techniques. Okay. So now we have to discuss today's, that is what classification. Okay, classification of different types of process variables. So we have to know in our process instrumentation and control, it has uses different types of process variables. Okay, so this process variable, it is also dependent in the physical parameter of the different states also. Okay, so in the dependence of the physical parameters, we have to broadly classify these process variable. First we have to classify two types, that is the input variables, another one is the output variable. Okay, so this input variable, it is also classified into the particular parameter, that is when you have to use different types of physical parameter and convey the effect of the surroundings of these different types of process. Okay, and in this time the output variable, it's convey the effect of the process on the surroundings also. Okay, so this input variable and output variable, these are both are the different types. One is user is given, that is user is given, that is the input variable. Okay, or vary that input variable, and finally process or plant, it is process the different types of input, then finally you have to given the results. Okay, so in our process control industries, this input variables, it is also classified into another two types. One is the manipulated variables, another one is the disturbance variables. So this manipulated variable and disturbance variable, it is also two types of variables. Okay, here disturbance means that is a different types of inputs you have to given or you have to control. That is sometime uh, instrument, it is label measurement. Okay, sometimes it is also speed measurement, sometimes it is also pressure measurement. or sometimes it is also uses that is a temperature control device. So these are the basically different types of variables we have to use in our process control industries. So in the given types of variables, we have to classify this input variable into two types. One is the manipulated variable, another one is the disturbance variable. In this respect, output variables, it is also classified into two types. One is the measured variable, another one is the unmeasured variable. Measured and unmeasured, all of you know. Measured variable means which variable it is measured and also recording in the future response. Okay, that means you have to measure temperature. Okay, a particular a heating element or any furnace or any device. So you have to measure time by time the temperature changes. Okay, so and this temperature result of the view, that is temperature time by time it is changes graphically, we have to plot it, or any other devices we have to also store or save for the future reference also. So these are the basically measured variables. Another one is the unmeasured variable. This unmeasured variable output we have to receive from the output sections, but in this variable it is not measured. So this is called the unmeasured variables also. Next, this output variable, it is control, that is a uses of the different types of control valve. Okay, that is a controller part. So these output variables are the ones to be controlled. The particular variable to be regulated is termed the control variable. Okay, so control variable means that is a different types of control parameter you have to measure: temperature, speed, level, etc. So these are the basically particular output variable which is mostly we have to control. This particular variable to be regulated is termed the control variables. Next, the desired condition of the control variable, it is called the reference or set point. Okay, so previous we have to all of you known in your control system, all of you read this block diagram of the closed loop system or open loop systems. So in the closed loop system, all of you seen the one is the reference input. Okay, reference or input or set point input we have to implement it. Okay, where the input is given and this reference point or set point, it is connected between the another one, that is feedback loop also, another one is a controller part also. So this desired condition of the control variable which is controlled by the this part, that is a reference part or set point, it is called the reference input point or set point. Okay, and this reference point or set point, it is also implemented with the feedback loop. So in your control system, all of you seen in the closed loop control system, we have to use as one feedback loops. Okay, so this feedback loop we have to use as in the response of output and the input responses. And this feedback loop, it is connected between the output variable to the reference input or set point. Okay, so this is this desired condition or this desired point, it is called the reference or set point. Next, manipulated variable. So we have to classify it into two, that is a manipulated variable, another one is disturbance variable. So this manipulated variable are the ones which are chosen to the effect the change in control variable. Okay, the selection manipulated variable depend on how it affects the control variable in terms of speed and magnitude. So this is another one conditions. So this manipulated variable, whatever we have to given in the input section of the process control plant or industries, so this manipulated variable are the ones which are chosen to affect the change in control variable. So that means user or automatic process that's we have to use this in our input section, which is changes different types of control variable. So this is called the manipulated variable. So certain time you have to changes the variable part. So this selection of manipulated variable, it depends on how it affects the control variable in terms of the speed and magnitude also. Okay, so this is the manipulated variable. Another one we have to classify in input variable, that is the disturbance variable. So this disturbance variable, it can be measurable or immeasurable. So in this condition, these desirable variables, sometimes it is also measurable and another time it is also immeasurable, that is not measured. Okay, so these disturbance are also known as the load. Load means what type of input you have to given in the process industries in the input variables. Okay, so this disturbance variables or disturbance, it is also known as the what type of load you have to given. So they could arise because the ambient changes or change in quality and or quantity of input variable. Okay, so please remember this thing, this is very very important. This disturbance variable, it is also measurable, sometimes it is measurable or sometimes it is also immeasurable. So this disturbance, it is also known as the load of the input, load of the input section of the process plant. And this load or the disturbance variable, it is sometimes it is also because of ambient change of the quality changes, or sometimes it is also quantity of the input variables. Okay, so these are the basic classifications of the process variable. So I just conclude this classification. So first we have to classify this process variable into two parts. First one is the input variable, another one is the output variable. Okay, then this input variable, it is also classified into two categories. One is the manipulated variable, another one is the disturbance variable. And also this output variable, it is also classified in two categories. First one, that is the measured variable, another one is the unmeasured variables. Okay, and another one, this disturbance variable, these are the input variables, there is a disturbance variable, it is also classified in two categories, that is one is measured, another one is the unmeasured. Okay, so this is the basically classification of the process variable. Okay, so it is clear all of you? Please respond me, it is clear or clear not? No one is reply.
Yes, sir. Clear.
It is clear all of you?
Yes, sir.
Okay, so we can go next. Okay, sorry. Next we have to discuss one examples. Okay, so till now we have to discuss different types of process parameter, process variable, classifications, what is the benefit, what is the basic requirement, etc. So now we have to discuss one examples. Okay, how it is implemented. So in this slide here you can see, just um, okay, so here you can see, this is a one examples we have to discuss. So this is a continuous stir tank heater. Okay, sometimes it is also short terms it is called, that is CSTH. Okay, so this CSTH, that is called continuous stirred tank heater. That means it has a one tank and it is filled by the any types of fluid, that is water, or sometimes it is different types of fluid you have to use, and it is also heated, okay, by the one heating element. So it is the examples of the continuous stir tank heater. Here in this picture here you can see, this is different types of parameter we have to use. First, this is the steam flow. Okay, here you can see this is the basically steam flow, and where we have to use as one valve, and here FST and TST. What is the FST? FST is the steam flow. Okay, FST is the steam flow. steam flow. Okay, and then is the temperature. T is the temperature. One is the input, that is the Fi, and another one is the Ti. Okay, this is the basically Fi and Ti. Fi is the flow rate of the liquid, any types of any liquid you have to use it, and Ti is the temperature of the respectively fluids also. Okay, then these are the basically initially flow rate and temperature we have to measure. Here we have to denote it, that is F0 and T0. So this F0 and T0, F0 is the primary flow rate. Okay, that means when you have to any fluid you have to fill the tank or reservoir, and T is the T0, that is the temperature of the initially of the device. So this F0 and T0, it is the flow rate and temperature of the outlet stream of the CSTH. CSTH, that is a continuous stir tank heater also. Because of the constant stirring, temperature at the outlet, that is T0, that is a T output. Okay, it is assumed to be same as the temperature inside the tank. So when this liquid it is also heated, so at first this liquid we have to use another plant or another process for the heating element of the heating element. Okay, so this temperature, when this output it is coming from the output section, this temperature and inside of the liquid level of the reservoir or tank, the temperature more or less same. You have to assume in that. Okay, so this liquid level, here you can see these are the basically liquid level, these are the basically upper level, and these are the bottom, that is the lower level. So this H is the basically liquid level we have to denote it here, and Q, this is the Q. Q is the amount of heat added in this reservoir or stir tank heater. Okay, so this is the basically one heating coil which is heated the liquids also. So in that case, these are the basically input variables, that is Fi, Ti, and another one is the FST and TST. Clear? So this FST and TST, one is the fluid flow, another one is the temperature we have to control here. This one, that is Fi and Ti, one is the flow rate, another one is the temperature of the respectively points. So these are the input variable. Okay, these Fi, Ti, and FST and TST. Next, this is a basically output variable we know, that is F0 and T0. F0, that is the output of the flow, and T0, that is the T output. These are the basically output temperature of the fluid flow. Okay, so this is measured, this FST, it measured selected as a manipulated variable, in which case Fi, Ti, TST are the disturbances also. Okay, so if the aim is to maintain the T, that is the temperature, at a particular temperature, then T becomes the control variable. Okay, so in these examples we have to control the temperature. Okay, because here you can see, just like as example, the temperature of a liquid we have to deserve, that is 200 degrees Celsius. Okay, so at that time you have to select the temperature sensors, that is 200 degrees Celsius. So this valve, that is this temperature heating element, it is heated this liquid, that is up to the 200 degrees Celsius also. Then this liquid you have to output, and then it is uses another part also. So this is the basically one closed loop examples of the continuous stir tank heater, where we have to use continuously the liquid of the reservoir or tank. Okay, it is clear, all of you?
Yes, sir.
Okay, so this type of examples of various types of example we have to use in our process industries. Next, here you can see this is another one. This is a block diagram representative of the any process control system. Okay, this is very important. So in this part, one question also coming in your exams. So what is the basic block diagram of a process control or industrial process plant or industrial process unit? Okay, so please note down this. These are the basically one block diagram which is represent the industrial process control or plant or systems. Okay. Just wait. Okay. So here you can see first we have to use this. These are the basically input point. Okay. First all of you please see this diagram, block diagram. Then we have to discuss. This is also another one part. So this is the basic block diagram of the any industrial process or plant or industries. So here you can see we have to use a first input from here. This input it is coming into the, this is called the reference point, or sometimes it is called the set point, which is control the overall sections, that is the input variable. Okay, we have to tell in our previous slide, this is reference input or set point, which is coming from the input sections, and this set point or reference input point, it is connected to the two parts. Another one, this is the controller part, that is these are the basically controller part, these are the controller sections. Okay, this is controller sections, and another one it is connected here. You can see this is the feedback loop or feedback elements also. Okay, so please remember these things also. This is set point or reference input point, which is connected in the two sections. Another one is the inputted the controller part. Another one it is also connected to the feedback loop or feedback path. Clear? It is clear?
Yes, sir.
Okay. Next, here you can see this set point or this reference input point, which is given the input to the amplifier section. What is amplifier? I am telling in previous classes also. Amplifier, that is amplify the any input signals. Okay, that means user or any types of process which is received from the input sections, and this amplifier which is amplify the signals. Okay, these are the basically we have to call the amplifier sections. So this amplifier which is amplified the different types of signals, then this amplifier which is send the signals output to the controller part. Okay, so this controller part which is control the amplifier signals, then this controller part which is given to the output to the final control element. Okay, this final control element FCE, this is also connected to the process or plant, where the input variables which is processed broadly, then the particular desired output we have to receive from the output sections. Okay, so these are the basically output section, but this in this output section we have to use another loop. This is called the feedback loop. This feedback loop which is connected another block, that is sensor or transducer, which is we have to use this in our different types of sensor or transducer in this loop. That means temperature sensor, flow sensor, level sensor, speed measurement transducer or sensor, anything like that. We have to use it in this sensor or transducer part. Then this sensor or transducer part, which is output the feedback loop, that is a feedback amplifier. This feedback amplifier, which is connected to the reference input or set point. So this is a one closed loop process. Here you can see this process is continuing up to dependent the timing of cycles or what time the input it is you have to given, this process is continuing. Okay, so this is the basic block diagram of a representation of the industrial process controller plant also. So this question is very important, and for your semester exams question is coming that type, draw the block diagram of process control industries or industrial instrumentations, anything like that. Okay, so that time you have to drawing this diagram and discuss shortly point by point. Okay, it is clear all of you?
Yes, sir.
Yes.
Okay, anyone any questions or any doubts? So please also clarify me. Okay, another important, that is the example we have to given in process engineering. This is the one liquid level tank level controller. Liquid level measurement, that means all of you seen the in your house or any office or any places. Here we have to use the water pump controller machine. That means this pump, it is rotated, and then this water is filled by the tank. Okay, then the when the tank or reservoir, when it is filled, this is a, we have to use this one transducer, that is sensor, which is measured the level. Okay, that means here you can see this is a basically fluid inlet. This fluid inlet, which is dependent on the motor operations. Here we have to use this water pump motor control system, which is rotated and which is given the output from the fluid from the input of the reservoir of the tank. Then this water is filled. Here you can see one water valve, that is outlet valve we have to use this. Here this water, it is outlet from here, and this valve, it is also control this the outer side of the fluid. This fluid outlet we have to use as our different purpose also. And this valve, it is also connected one another loops also. Here you can see. Okay, this is a basically level controller. We have to use this one set point. This is TC. This is called the level controller set point, which is control the level of the liquid level of the inside of the tank. Another one is a level transmitter, which is receive the signal from the level sensor. Here you can see the one level sensor we have to use this level sensor, which is uses in our inner side of the tank, which is continuously measure this level of the liquid sensors. Okay, then this is continuously signals given in the level transmitter, and when the tank, it is filled by the water is topmost level, this is valve, it is shut down or off condition. That time this motor, it is also automatically off. Okay, so this type of closed loop control system, or any, that is a process control system, we have to use as automatically it is working. So this is another example, that is a liquid tank level controller systems. Okay, so in our previous examples, we have to discuss this is the steer tank temperature control system. So this steer tank temperature control system, this is a basically block diagram of this previous examples. Here you can see this is a basically we have to discuss the continuous steer tank heater, where the liquid is heated by the heater. Particular desired point you have to select it, or user you have to select it. So these are the basically block diagram of this device. Okay, because here you can see this is a set point. That means you have to, your user, it is set the input section. Okay, this is also connected to the one controller part, which is control the overall actions. Then this controller part, it is given the another one signal, that is PT, that is in the heater point, which is heated the liquid. Then the output is coming from here, the steer tank. Okay, this steer tank is filled by the water or any types of fluid you have to use it. This is TIT, that is the temperature inputted here also. Then these are the basically finally output sections, where the temperature, it is same to the inside of the temperature and outlet of the temperature. Then this is also another one feedback loop we have to use this one sensor or transducer part. This sensor or transducer part, which is senses the basically temperature level of the liquid. Either this temperature of liquid, it is particular same to same in the selected variable, then this is outlet. And when this level, it is also below the temperature level, then again it is also heated. Okay, so this type of works done by this feedback loop. Okay, so this process is continuing process. So this is a basically block diagram of a steer tank temperature control systems. Okay, it is clear all of you? Anyone any questions or any doubts? So please ask me. This type of question, it is example oriented question, is also important for your exam. That is, draw the block diagram of steer tank temperature control systems. Okay, that time you have to draw this block diagram and discuss the previous slide we have to discuss. Okay, so this slide basically most important. So this is the one broad question also coming from your semester exams. So please note down this question. It is very important. Block diagram of a industrial process control system or industries also. Okay, so we can go next. So everyone write your own name and roll number in the chat box also. And CR, please screenshot. Please take the one screenshot. Who is CR?
Yes, sir, I am Krishnadev Vishwakarma.
Okay. You take a one screenshot right now. So okay, we can go next another part. So in the corresponding block diagram, we have to discuss in previous slide. That is the one is the temperature control system. That is the steer tank temperature control system. Another one is the general block diagram of a process industry process plant. So in this view of this diagram, so we have to conclude these are the basically components of a process control industries we have to use this. Okay, so this is the another important part. So what is the basic components of use in the process control industries or process control system, anything like that. So please remember this thing. These are the basically main important variable or components we have to use. First, that is sensor or transmitter. Okay, so what is sensor and transmitter or transducer? Sometimes it is also called transducers. So this sensor transmitter, it is also called the primary and secondary elements, which is used for the measurement of variable. Okay, and this variable, it is to be controlled and transmission of the measured value to the controller part. So please recall the block diagram part I am discussing previously. So just recall these sections also, because these are the basically different types of components we have to use in the block diagram of the process industries. So first we have to conclude that is a sensor or transmitter part. What is sensor or transmitter part? It is called, firstly, that is a primary, and this is called the secondary element, which is used for the measurement of the different types of variables to be controlled and transmission of the measured value to the controller. Okay, then this is controller part. What is controller? These are the basically brain. That means human brain. Our brain, it is also totally control of the human body. Okay, that means you have to walking, you have to singing, you have to reading, you have to watching the movie, etc. You have to diving, etc. So these are the basically well done. It is controlled by the human brain. So in the process control industries, this controller part, it is a brain. Okay, so this is a brain of the control system that takes the decision to maintain the process variables at desired value or set point. Okay, so this controller part, it is a main thing. It is a brain of any process control industries or plant, and which is takes the decision to maintain the process variable at the desired value or set point. Another one is a final control element. Okay, so this is another one. This final control element, it is conveyor. That means this final control element, it is a different types of instrument we have to use in this final control element. That means we have to use the different types of valve. We have to use this. That's like you have to see. These are the basically example. This is the basically valve we have to use this, and this valve, it is a final control element. Okay, so this valve, another types of conveyor belt. Conveyor belt we have to use this industry purpose, or any types of electric motor we have to use this in this final control element. Okay, so I am repeating one thing again. So this is a final control element. This final control element, which is connected to the controller part, another one is the process or plant part. These are the basically called final control element. The example that is a different types of control valve we have to use it, or any types of conveyor belt we have to use it, or any types of motor we have to, that is electric motor we have to use it, or any types of variable speed pumps we have to use it. So this type of element or this type of instrument we have to use it in this final control measurement. So this is used to take the action for implementing the decision taking by the controller part. Okay, so this final control element which is dependent on the controller part, because this controller part, it is the brain of the process control system, which is uh, given the command to the final control element. This final control element, which is different types of we have to use this process control industries. That is, sometimes it is also control valve, sometimes it is also different types of speed control motor, sometimes it is also use a conveyor, sometimes it is also electric motors. So this is used to take the implemented, sorry, take action for the implemented the decision taken by the controller. Okay, it is clear, all of you?
Yes.
Okay. So these are the basically automatic process. So these following terms are is the automatic process control system. Here you can see there is a control variable or process variable. Another one is a set point, that is SP or reference point. Another one is a manipulated variable. Another last one, that is a disturbance. Okay, so these are the basically coming into the automatic process control. That means which process control plant which is automatically working. So first one, that is the control variable or process variable. Okay, so this control variable or process variable, it is a variable that must be controlled or maintain the some desired value. Okay, so we have to take example in previously, that is a liquid level measurement, tank liquid level measurement, or temperature control measurement. So in this control variable or process variable, it is a variable that must be controlled or maintained at some desired value. That means setting the temperature. I am telling the previous example, you have to set the temperature 200 degrees Celsius. So this is called the control variable or process variable method. Another one is the set point or reference point. So this set point or reference point, it is the desired value of the control variable to be maintained all time. That means this set point or reference point, which is maintain the variable, control variable, the desired value you have to, or user you have to say, setting in the control actions. Okay, this is called the set point or reference point. Number 3, that is a manipulated variable. This is a one type of variable. It is used to maintain the control variable and it's set to the set point also. So these valve position in our given examples, previous examples we have to given. So this valve, it is a manipulated variable which is control the overall actions. That means this valve, it is control the water inlet or a water outlet, or valve is control the heating temperature, etc. So this is called the manipulated variable, which is used to maintain the control variable at its set point also. Last one, that is disturbance. So what is disturbance? Disturbance is a variable that causes variation in the control variable. Okay, that means there is a number of disturbance we have to uses in our different types of process loop. That is, previous example we have to uses temperature controller system. That means another one, inlet process flow, fluid flow system, or any heat content. It is called the disturbance. Okay, so these four are we have to uses in the automatic